Hello all, welcome to Coach of START163. We are solving problem Lexio Swap. So in this problem, we are given two strings S and T, both of which contain only letters A and B. And we can perform the following operation on string S. That is, we can choose an index I, that we are considering 4 characters right now, that S of I plus 1 is equal to S of I plus 2, and at the same time S of I is not equal to S of I plus 3. That is, it has to be, since we are dealing with A and B, the first 3 numbers can be equal and fourth number should not be equal to that. Or similarly, that we can have the and first number unequal and last 3 numbers equal. So we can have either A triple B or triple A then B. Then delete the characters at indices I plus 1 and I plus 2. That are the same characters that are middle equal characters that we can remove it. The remaining part are concatenated. So simply we are removing those two middle equal characters. For example, we have A, B, B, triple B and A. The operation is performed as I is equal to 2, which is valid since S2 is not equal to S5. So we have S5 as 1, 2, 3, 4, 5, B and A. We'll be removing these two B's because this A is not equal to B, as I consider that A triple B or triple A B. So if we have a triple B, so A and B are not equal, we'll remove this middle B's and we will be left with double A B A. So we have to tell that can we perform this operation as many number of time we want and finally convert S to T or not. So we have to solve this for Q number of test cases, and each of the test cases will have S and M, N and M are given. That is, the length of string 1 is N, string 2's length is M, and we both the strings contain only A and B's. Constraints are 3 into 10 to the power 5. That is, we have to use some big O of N or big O of N log N. Okay. So if we see the examples, let's try to analyze it like before jumping into the solution part. I have broken down this into chunk wise, like a chunk of B together, then chunk of A together, chunk of B together. We have this as, this will look like B's A, B, A. Similarly, this will look like B, A, B, A, B, B. So I have broken down into the segments of A. So what we can do is we have to remove from S the elements, like if 3 consecutive, fourth one not equal, remove the middle 2, or initial 3 equal, 4 not equal, remove that. What is I'm trying is, can we think in the reverse order, that we are trying to insert elements in between those, that if these two are not equal, we can apply 2 B's over here, and not only 2's, any multiple of 2 B we can add it over here, because these two are not equal, we can apply any number of B's here. Again, similarly, these two are not equal, we can apply any number of A's here. So if we see that if these two chunks are same, that is B A B A, similarly B A B A, I have to add 2 B's, I can add it over here. Then here I have to add extra 2 A's, I can add it over here. The B will remain same. I have 3 A's over here, 2 A I can add it. So this is the basically idea that we are trying to follow. Similarly, if we go to second example, we have A and B, these are not equal, I can insert 2 A's over there. Again, I have 2B, I can not insert over here. Why so? Because I can insert 2 B's and only 1 B is present. I will have to add 2. This will differ it, so I can't do it. So that is why answer is no over here. If I go to third, here I can add B A is there, so 2 B's can be added over here. I have again 4 A's, again since multiple of 2, I can add it over here, and similarly I can convert this to now this. Instead of converting S to T, I have converted T to S back. So let's try to understand with code. So first, taking the N and M as input, ST as input, maintaining A and B. What A and B are doing? A and B are basically maintaining the counters of these A's and B's, breaking down into equal parts and chunks. That is, A will be storing B's count, A's count, B and A count. Okay. So I'm checking, starting the counter with 1, checking if the consecutive elements are equal or not. If that, incrementing by counter by 1. If not, I will push back my counter in A. For corresponding to S, I have maintained A. Corresponding to T, I have maintained B. Another thing to notice, when my last element is B, I am inserting negative of that. Why so? Because I have to distinguish between A and B finally when I will be jumping back to the conditions, that can I insert it or not. That I have to distinguish that negative part will denote B and positive part will denote A. That is why I'm taking negation over here. Similarly, after the loop also, I will check that last element was B, add it whatever the counter you have with negative, otherwise add it with A. Similarly, I'll do the same thing with string T, and I'll again push that all the stuff in B. Now, Another thing to note, now we are done with our segments. Now one thing to note, that the size of this segment should be equal. What we saw in example 2, that the size was not equal, that it has three, it's got three size, three chunks were possible, it got four. So we finally landed up that we cannot make it equal. So first condition was that yeah, their sizes are unequal, simply see out no and return it. We don't care about it. Another thing is when size is 1. If their size is 1 and they are not equal, let us assume I have 3 A's in in string S, and in second string I have 4 A's. I can not, or 4 A's or 4B, anything I have, I can never make them equal. So if their size is only 1, they have to be equal, otherwise we can't make them equal because we don't have that difference part so that we can insert or remove part. I hope you understand over here. So yeah, after that, what we need to do is we have to compare chunk wise. A is greater than 0 and bi is less than 0. So this is because I mentioned that we'll maintain negation for b, that if we have ai greater than 0, that means this eighth segment is my a and bith segment is b. So this has to be same because they have to go in order, then only I can add in between and make them go. I have basically, my block should remain same. Inside the elements I can update it. So if they are different, I cannot make them equal. So if I have a in string s and b in another, and if I ab and ba, I can't make them equal. Okay, so that is why if they have, the blocks should be correspondingly equal. Similarly, if a is less than 0, that is my ai is b and bi is a, so in that case also it will be no. Another case will be that if modulus 2, I told you that we can add only elements that can be added at a multiple of 2. So if these are not equal, that is if their moduli 2 are also not equal, then they will create a mismatch in increment of the counters. So that is why, again, representing that see out no, because this also case, and simply we don't need to compare, we found only one case, simply see out no and return it. Another one is then when my size of b is greater than my size of a. So this is definitely not going to be answered, because at the lower part is a string after the removals. So if after the removal I have the larger element in it, so that does not make sense, right? So that is why also taking this no case and simply returning out of the solve function. And if all these cases are satisfied, simply returning cout yes, printing yes, and then going after the loop. So that is all we have to do in this problem. If you better to visualize it using pen and paper and break it down into segments and try to visualize all those conditions, then only you will be able to better figure it out. So yeah, that was all for this problem, guys. If you have any query, do comment it out, and if you like the video, hit the like button and do subscribe for more daily content. Thank you.